This session is going to be an overview of the strengths and many of the limitations of an economic approach to evaluating changes, interventions, new programs, new technologies, etc. So you can see for the photograph, I'm being very literal. It's an overview. Otherwise, I couldn't think what photograph illustrated what I wanted to talk about. Anybody get any idea what that might be a view of, or where it might be? Yeah. It's actually the view you get from the roof of the Oslo Opera House. And the interesting thing about this building, well, it's right by the water, as you can see, it's designed so you can just walk up onto the roof. You don't climb, you don't go in a lift, there's not stairs. It's largely just an incline that leads you around the building and onto the roof. It's a very interesting design. This is a view looking down. I didn't go into the Opera House, but from outside it's definitely an impressive building. Right. So, I think the place to start, and what I'm going to try and do in this lecture is pull together some of the elements I've talked about so far and put them all together. There's a whole series of challenges involved in making robust estimates of cost effectiveness. And you'll have got a sense of some of these already, but I'll add a few more in. And so in short, I want to emphasize that it can really be quite difficult to come up with convincing estimates of cost effectiveness. It's not an easy task, it's not a trivial task. But of course, what I'm going to be arguing is it's worth doing. It's difficult, but it's worth doing. The first consideration whenever you undertake an economic evaluation is, what are you comparing? So you can't do an economic evaluation without some element of comparison. So for example, I've just been talking about smoking cessation this morning. You can't evaluate a smoking cessation program without comparing to not having a program. Or, for example, if you're looking at some new treatment for a particular condition, plaque psoriasis, you can't consider is ustekinumab, one of these MABs, is cost effective or not, without comparing it to whatever your current treatment is. So I'll say a bit more about that in a minute. That choice of comparator is very important. Second set of issues, which I'll reprise with you, are this issue of modelling time spent in different health states. And this is what we spent a lot of time, our time, on in this second lecture. It has to be done if you're going to get a realistic picture of cost effectiveness. But it's again not straightforward. The third issue on this list concerns producing estimates, but in particular unbiased estimates, of the treatment effect, of how well the intervention works. Now, there's lots of challenges here. One of the most obvious, particularly when we think of clinical trials, is that the patients who are in clinical trials are typically rather different from the patients in routine clinical practice. In routine clinical practice, the patients tend to be older. In routine clinical practice, the patients tend to have more comorbidities. In routine clinical practice, to put it bluntly, patients are less well looked after. If you get a chance to be in a clinical trial, maybe you should take it, because you'll be looked after very well. There'll be a very clear protocol to follow, and they'll really try and keep to it. The real world's not like that, or is less like that. Now that is quite a problem, or quite a challenge, because it means you're getting an estimate of how well a drug or some other therapy works, but how well it works in a carefully selected group under fairly controlled circumstances. But of course, what we really want to know is how well would this drug work in the real world, in routine practice. Another issue that arises with obtaining unbiased estimates of treatment effects is that sometimes you've got multiple sources of information. And the question arises, how do we compare, or how do we combine information from different sources? Now, occasionally you've just got a single trial, there is no other estimate of the effect. But quite often, you've got a series of studies that tell you something about how well the treatment works. And the challenge is how to make the best use of that series of studies. And that leads me on, and I'll say a bit about it, a bit more detail about it shortly, to something called indirect treatment comparisons. Indirect treatment comparisons. This is a situation where you don't have data, what we call head-to-head trial data. You don't have data comparing intervention A to intervention B, but you do have data comparing A to C or B to C, but you've no direct comparison between A and B, which might be the thing you're interested in. And that's where indirect treatment comparison becomes an issue, and there's quite a lot of challenges there, and I'll say more about them. And then the last on this list of challenges in producing robust estimates of cost effectiveness is the topic that we spent a bit of time on Wednesday morning, and that's valuing the time that patients spend in different health states. So when we looked at genetic preference-based measures, EQ5D, things like that, when we looked at mapping from a condition-specific to a genetic measure, all those issues arise or can arise in an economic evaluation, making it harder to get a good estimate of cost effectiveness. So, comparators, a bit more about comparators. The comparator for the technology that's being assessed is very important. It's very important because depending on your comparator, this will to a large extent determine your incremental costs and your incremental benefits. Or in our case, incremental benefits might be the incremental QALYs. The additional QALYs you get, or quality adjusted life years, the additional quality adjusted life years you get from the intervention. Now, if you choose a comparator which is bad enough, you can make your intervention look very good. And this is not a trivial problem because our manufacturers of new drugs are very keen to show how good their drug is. And so they may well try and compare to something that's not too good because it makes their product look much more attractive. There's a number of considerations to be made when you're thinking about suitable comparators. An obvious potential comparator might be routine clinical practice. Routine clinical practice. And in many cases, it is the obvious comparator because you've got some new treatment that you're thinking of introducing. And so what to compare it to? Well, let's compare it to what we're currently using or doing for these patients. That sounds very straightforward, but it's not always the case that we know or we can identify routine clinical practice. You'd think it would be straightforward, but sometimes it depends what part of the country you're in as to what is routine practice. It can vary. I'll give you an example. If we're looking at treatments for early stage prostate cancer, depending which centre you go to for treatment, you could be more or less likely to receive perhaps a surgical intervention. Some centres will be more likely to give you drug therapy. Some centres might use brachytherapy or other technologies. So the answer to the question, what is routine clinical practice for early stage prostate cancer? There's no simple answer. It depends which centre you go to. Another consideration in choosing comparator might be cost effectiveness. You should never choose a comparator which itself is not cost effective. I'll say that again. You should never choose a comparator which is not cost effective. Because if you compare a new treatment, to an existing treatment which is not cost effective, you haven't really learnt very much. You might learn that the new treatment's better than the old treatment, but if the old treatment itself was not cost effective, was not a good use of resources, so what that the new one's better? It may make the new one look cost effective, but it's cost effective compared to something itself which was not cost effective. Sometimes, perhaps the most appropriate comparator is natural history. This would be a situation where the condition that you're looking at, there isn't really currently any suitable treatment. And so, most appropriate thing is what happens if the patients are simply left with that condition. What is the natural history of it? Sometimes it's argued what you should look at is what is expected to be replaced. So compare your new treatment to what you expect would be replaced by the new treatment if you were to accept the new treatment. As I said, routine clinical practice is a very strong candidate as a comparator, but it's not going to always be appropriate. For example, it might not be best practice. There's a condition called hyperuricemia, which involves acetic acid building up in your joints. And what happens is crystals form, and crystals in your joints can be very painful. The general condition is sometimes called gout, but hyperuricemia. Now, if these crystals are not prevented, if the buildup of acetic acid is not prevented, it's going to be quite painful having these crystals in your joints. And if it's left over time, it can cause major tissue damage and longer term disability. So in that condition, what is routine clinical practice? Well, until recently, the routine clinical practice in England was to give a particular drug. I'm going to try and struggle to remember the name of the drug to come back to me. But to give a particular drug, I think it was a 200 milligram dose. That was routine clinical practice. But it's not best practice. It's well established that best practice is to start by giving a 200 milligram dose to these patients, but then up titrating to a bigger dose if it's not working. Up titrating as far as 800 milligrams. And if you do that, most patients can tolerate the stronger dose. And for most patients, if you increase the dose enough, it resolves the problem. But it remains true that the standard routine clinical practice is to give a 200 fixed dose. So you have to be careful. What is routine may not be best practice. And so then there's the issue, should we really compare to routine practice or should we be comparing to best practice? Okay, I could do a memory test now, see if you remember any of these issues. But moving on to modelling time spent in different health states. Now just to remember, this is so important. It's going to be a major determinant of your costs and your QALYs. Because depending which health state you're in, this usually influences your costs. And so if you spend longer in particular health states, that's going to have an impact on the cost of your overall treatment. More than that, the time you spend in a particular health state is directly related to the estimated QALYs or quality-adjusted life years that you're going to experience. And the better the health state, the higher the score we attach to it. So the QA, the quality-adjusted part, is increasing. So that's important. We need to know how much time patients will spend in different health states. But of course, the second thing is, we don't usually know that. We don't usually have clinical trial data that tells us that. What we have is some limited period of follow-up. And so we have to go from that to predicting the future, predicting what health state and for how long patients will spend time in. And as I tried to highlight, and I just use one very simple example, azacitidine for myelodysplastic syndromes. Depending how you do this extrapolation, you can get quite markedly different answers. You get different results depending how you do your prediction or extrapolation. Now, this whole area has moved forward quite rapidly in even the last 10 years. If you look back 10 years ago and look at economic evaluations, they were much cruder at predicting the future, extrapolating from the trial data to a lifetime perspective. And I'm sure it'll continue to change. It's all getting much more sophisticated. And I gave one example of this. This was a particular issue of treatment switching. You remember treatment switching was where a patient starts on one particular treatment, but possibly when the disease progresses, they switch to the other treatment that's involved in the trial. And the problems that gives rise to, and I touched on some of the techniques that are available for trying to control for the switching. Now, this list of things is a list of potential difficulties or challenges if you're going to get an accurate estimate of cost effectiveness. Back to our main list. Producing unbiased estimates of the treatment effect. I've got so many of these arrows going forward and backwards. I have to say I'm scared as to what I press next. I'll try this one. That's comparators. That's that one. No, it's this one then. Okay, so it's this issue here. Taking information from different sources and combining it. Now, as I've said, what we most want to know, at least in a drug context, but it's true also, if we think of this morning, public health interventions, you're most interested in what we call head-to-head comparisons. The new thing with maybe current practice or best practice against the new thing. Is this new approach better than what we think is currently best practice? More than is it better, is it a better use of resources? Is it cost effective? Now, frequently, and this happens quite often with new drugs, we don't have head-to-head data. Partly it might be because drugs take a long time to develop, and so what seemed a good comparator back at the time they planned the trial has now changed. That's a possibility. It's partly also regulators are most concerned not with cost effectiveness, but concerned with safety of a drug. And if you're investigating drug safety, sometimes the best comparator is a placebo. Because then you'll get a much better idea of the relative rates of adverse effects. For these reasons, quite often you don't have a head-to-head comparison of the drugs you're most interested in. So, what you have to do is engage in indirect comparison. And this involves, this general area is called evidence synthesis. You would, just to repeat, you would prefer head-to-head data in order to get an estimate of your treatment effect, but you haven't got it. But there may be evidence out there that's still useful. So, for example, there may be a series of trials involving at least one. While it helps my flow going back and forward with these arrows, it doesn't help a lot for handouts. Don't think PowerPoint have worked out a good way around that yet. Anyway, so apologies, but maybe if I numbered the slides, that would have been the way to do it. Yeah, you'll have trial data that maybe involves your intervention, but not your comparator. Or some other trial that involves the comparator, but not your intervention. And so the question arises, can we still use that information in order to help get an estimate of the treatment effect? So, these are the different situations we might have. What we'd really like is a trial comparing treatment A with treatment B. That's what we'd really like. Assuming A is perhaps a new thing and B is best practice or something like that. So we'd like that. And that would give us, in principle, a good estimate of the treatment effect, a good estimate of how well drug A works. We might not have that. What we might have is what are called single-arm trials, where all the patients got drug A, and some other trial where all the patients got drug B, but a single arm to the trial. So no randomization of patients at all. And this is what's called an unadjusted indirect comparison. Now, I'm sure you can appreciate immediately how suspect this could be, how vulnerable to bias. Because suppose drug A works, cures 50% of the patients in its single-arm trial, and drug B cures 40%. Can we therefore conclude A is better than B? Well, no, because the patients might be completely different. These patients might be treatment naive. These may have heavily pre-treated, and you've tried lots of other treatments and they've not worked. The age of the patients could differ. The comorbidities could differ. Severity of the condition could differ. So this sort of comparison is not to be thought of. Think of it in the sense of it's something not to do. On the other hand, you might have what's called an adjusted indirect comparison. So you may have a trial that compares treatment A with treatment C, and another trial that compares treatment B with treatment C. And because the two trials have a C arm in common, the argument is we can then compare, by comparing how much better A is than C, and compare that with how much better B is than C, we can then make the comparison between A and B, because they have a common comparator. So we're not, in this case, we're not interested in C. We're not thinking about should we use C. We're simply using it because the available data gives us a comparison between A and C and B and C. And this is what's called an adjusted indirect comparison. Compared to the unadjusted, the adjustment is they have a common C arm. Finally, what we might have is this series of trials. We might have a direct A to B comparison, a comparison between A and C, a comparison between B and C. Now, health economists and some others argue that if this is what we've got, we should try and use it all. Some people, Cochrane Collaboration, you might have heard of, who are a big international organization dedicated to improving evidence-based medicine, they argue if you've got a direct comparison, why would you look at this other data? It was a direct comparison A-B that you needed. The health economists and others, some others, say that you should always use all the evidence you've got available. And the AC-BC comparisons are also relevant evidence. Of course, there's an issue of how you combine information, and also what weight should you give the direct comparison compared to the weight given to the indirect comparison. But it's quite clear, at least to some people, that you should at least use all the information. Here's an example. So I like to introduce real examples just so you see that it's not just a sort of theory or something like that. So dabrafenib is a treatment for unresectable or metastatic BRAF V600 mutation positive melanoma. That bit doesn't really matter. I mean, it matters, but it's melanoma, so it's skin cancer, or a form of skin cancer, and late stage. If you're unresectable or if you're metastatic, you're fairly advanced. So dabrafenib was in this case, the new drug, and recently approved was another drug, so new but not quite so new, called vemurafenib. And so the question was, this new drug, dabrafenib, should we be using it instead of vemurafenib? There's no head-to-head study. No study anywhere in the world randomized patients to dabrafenib or vemurafenib. So if we're going to make an estimate of how well dabrafenib works compared to vemurafenib, we're going to have to use indirect evidence. And fortunately, there was indirect evidence. There's a trial called the Break3 trial, which randomized patients to dabrafenib or dacarbazine. Dacarbazine is an older treatment for this metastatic melanoma. There was also a trial that randomized patients, the BRIM3 trial, that randomized patients to vemurafenib or dacarbazine. And so it's back to this idea that, in principle, we could compare how much better vemurafenib is than dacarbazine and compare that difference to how much better dabrafenib is than dacarbazine. There is a problem, however. Can anyone spot it? Well, yes, they had a dacarbazine arm, but remember, it's not the same patients. This wasn't a three-arm study. We didn't randomize patients to vemurafenib, dabrafenib, or dacarbazine. They're two separate trials. And so we are assuming, in making this indirect comparison, we're assuming that the dacarbazine patients in the vemurafenib BRIM3 trial are similar to the dacarbazine patients in the Break3 trial. Now, that's something we can, to some extent, check. We can look at the age of patients, we could look at their gender balance, we could maybe have some indications or markers of severity of their condition. But of course, that just lets us know to what extent the patients are a bit different. It doesn't tell us whether they're too different to compare. So potentially this is a very powerful way of identifying a treatment effect when you don't have head-to-head data. Do a comparison, adjusted indirect comparison, but you have to be careful to check that the patients in the dacarbazine arm or the common arm in one trial are sufficiently similar to the patients in that arm in another trial. Now, partly in response to that challenge, in recent years, researchers have started looking at something called matching adjusted indirect comparisons. matching adjusted. Now, what quite often happens is that a manufacturer has individual data on their product. In fact, they always have. They are the people who have the individual data on their product. But if the other drug is made by a rival, they've only got aggregate data. So in this, I don't remember who the companies were, but in this context, the makers of dabrafenib will have individual level data on the breakthrough trial. But all they have for BRIM3 is the published report in a clinical journal on the BRIM3 trial. And the published report doesn't give you individual data, it gives you an aggregate level. It tells you what the effect was overall. It tells you average age of patients. It tells you what proportion were male, etc. But this creates a possibility. If you've got individual data for one trial and aggregate data for another trial, you can reweight your trial so that the patients have the same aggregate characteristics as the other trial. So for example, try and make it, suppose in BRIM3, the patients were, half the patients were male, half were female. But in breakthrough, a third were female, 2/3 male. Now, it may not be a great example because for metastatic melanoma, gender may not be important. But suppose gender was a predictive prognostic factor. What you could do is reweight your individual data so that instead of it being a third female, 2/3 male, you could reweight it so it's 50-50. So your data then has the same characteristic as the BRIM3 trial, which had, say, 50-50 male-female. And that's a matching adjusted indirect comparison. Yes?
For example, if there are not only one prognostic factors, there are several. Age,
Yes.
gender, and the BMI, for example. So in that case, how we can give the weight or that any method?
Yeah, that's a very good question. Essentially, and usually there will be several prognostic factors. Yeah, I only use the idea of one to make it simple, to give the idea. What you actually do in that situation is you, using your individual data, you use some form of regression analysis, which relates the health outcome for each patient to their characteristics, to these prognostic factors. And so that analysis would allow you to say which factors are prognostic, which have a significant impact. And then you could use that model to predict what the outcome would have been if patients had the characteristics in the other trial. So in a sense, you're simulating what break3 tells you would be the outcome if you had a different mix of patients. So you've done an analysis of individual level data that shows to what extent, I should know metastatic melanoma better than this. Well, there'll be some measure of, there'll be various things that are prognostic. And so you're then able to, in your regression model, to predict that if someone has these characteristics, we predict this outcome. And so then you can take the characteristics from the BRIM3 trial and predict what would happen if it had been based on these individual patients.
So you mean that we use the full data of the three, and then how can I say, get the prognostic model and predict the results from the frame three? I see.
So it's quite clever.
Yeah.
It's not easy, and it's not going to be sort of always accurate, but you can see how it's quite sophisticated. And so it's a move on from this. This, we just take it on trust. The C arms are common to both trials, so we can then just look at this difference and compare it with that difference, and that's it. But that, as I say, is vulnerable to these two control arms being a bit different from each other. So this approach, matching adjusted indirect comparison, is one step forward. It's making the comparator arms more similar. It's kind of exciting. You know, it's sort of producing something new from existing data almost. But inevitably, it's not straightforward. And what we often find is we don't have very good data on what factors are prognostic. You know, there's some we think definitely are, some we're not so sure, and that's an issue. Okay. So it's a reweighting approach. And so basically, it allows you to control for differences in baseline characteristics. So in this case, if the dacarbazine arms had patients with rather different characteristics, this approach, in principle, will allow you to adjust for that. So it's quite a step forward. Okay, so the other set of issues that can be a challenge when producing a robust estimate of cost effectiveness were all to do with how do we value the time spent in different health states. And just to remind you, this is important because it's going to determine your QALYs. What this valuing time spent in different health states is really referring to is the QA part, the quality adjusted part of QALYs, or quality adjusted life years. To remind you, this was Wednesday morning, there's a limited range of preference-based genetic measures. Far and away the brand leader is EQ5D, but there are other ones, SF6D, Huey, etc. There's quite a few issues as to how we elicit preferences. Now, I didn't go into a lot of detail on this because it's the sort of thing you could have 2 whole lectures just on eliciting preferences. But you'll recall what I did talk about was the time trade-off method, or TTO. This idea that you ask individuals to do a hypothetical comparison between time spent in an ill health state, which you've described to them, and a shorter period of time in full health. And the basic idea is that individuals will be willing to give up some part of their time in ill health in order to be in full health. And so that's the time trade-off. And depending how badly they view or how severe they view the ill health state, the more time they would be willing to give up. Now, time trade-off is just one method. It is currently probably the most widely used method, but it is just one method, and it has a few problems, but I won't go into them in detail. So that was one issue. There's different ways of eliciting these preferences. Second issue is, having elicited preferences, we actually don't just want scores for a subset of health states, we want a full set of scores a tariff or value set. We want a score for every health state. Now, that's quite difficult because if you think of EQ5D5L, there are 3,125 different health states. And if you've done a survey that's valued 89 of them, you've got to get from the 89 health states to the 3,125 health states. And so there's issues there. Essentially, you model it and then make a prediction, but that's got its own challenges. There are at least 4 options when you want health state valuations for economic evaluations. One is, and this often is the preferred option, you want patient-reported data, but valued using public preferences. So patient-reported, that's the patient saying how they are. It's the patient completing, say, an EQ5D questionnaire. But the public preferences, the idea is the people who have scored the health states, the people you've done the time trade-off with, are not the patients, but the public. Now this is something it's worth us spending a little bit of time on, because it's not obvious to most people why we use the public. So one argument that's made is that patients know the health state. They experience the health state, they've got the condition. They don't have to imagine it. They know what it's like to be in that health state. The general public don't know that condition. They don't necessarily have any experience of that specific health state. So how can they imagine themselves in it? How can they give you a good, realistic valuation of how relatively bad or good it is to be in that health state? Do you agree? Should we get public to value it, or do you think we should get patients to value health states? For the reason they know it. It's not hypothetical. Mm-hmm. You agree? Yeah? But in practice, we almost always use the public. If you remember, I gave you a large table. This was EQ5D3L, had about 24, 26 countries in it who had valued the EQ5D3L using time trade-off. All of these were the public. It's true the Swedish study involved people valuing their own health state. And so for them it wasn't hypothetical. But for everybody else, individuals were asked to imagine being in a particular health state. Well, there's a number of reasons why that's the dominant approach. Now, there's a certain amount of discussion going on as to whether it should be, but one argument is this. In a publicly funded healthcare system, such as, in effect, Japan is publicly funded, predominantly, NHS in England is overwhelmingly publicly funded. In a publicly funded health system, it's the public we should ask because they are paying for it. That's one argument, a sort of political argument. Another argument is that, yes, patients have experienced the health state, so they don't have to imagine it, they've experienced it. But what seems to happen is patients learn to cope with being in a particular health state. And so over time, they start thinking, it's not so bad. Particularly a chronic condition where they may have little chance of getting out of it, or relatively low prospect of avoiding the health state. It's maybe a good thing that patients learn to cope. But the problem there is that we're then getting a different view of how bad or good it is to be in that health state. We're getting one that's been sort of adjusted by experience. And so if we're then thinking about what steps should we take, for example, prevention to avoid people getting into a particular health state, do we really want to know what the patient thinks of it eventually once they've coped? Or is it not more reasonable to be thinking about what the public regard, how bad or how important they feel it is to avoid that health state? The other argument that's made is, yes, the patient is the expert on that condition, but they're only in some of the health states you're trying to value. And you're wanting a valuation for all health states so that you can use your measure again and again, comparing different areas of healthcare. And so that argument would concede that patients are the expert on that condition, but would just emphasize that patients only have an experience of a subset of the health states. And the other sort of argument is, if we take EQ5D or some measure like that, the general dimensions are things we all know about to some extent, either through direct experience or through indirect experience, family members or something like that. And so there's an argument that we know what a restriction on mobility is. We know what pain is. And so is that not enough? Can individuals, the public, us, you, me, can we not reasonably imagine what a particular combination of these dimensions would be like? Now, there isn't a right answer to this. As I say, the dominant view just now is to use the public valuations. One exception to this was the AQOL, the Australian measure that I briefly introduced. They've quite explicitly valued it half, or roughly half, I think, with public values and roughly half with patient values. So there's still some work going on out there that would use the patients. Okay, there's that issue. But anyway, we've got various potential sources of values, and so there's an issue about which ones we should use. Definitely there's going to be an area, there's going to be more and more research going on. Already it's heavily researched, but I'm sure there's going to be more and more happening in the next few years. Right, now for a different sort of challenge, what I've been talking about so far were, in a sense, I'll call them technical challenges. If you're trying to get an unbiased estimate of cost effectiveness, that series of challenges I've just reviewed, they all arise. They're obstacles to getting a robust estimate of cost effectiveness. So they're obstacles to producing the data. They're obstacles to producing the number, the result. The next set of challenges are challenges involved in using economic information, so not the creating of it, but using it. Once information exists, the challenge is involved in using economic information to inform decision making. And here's a few. First one, and I mentioned this just in passing, increasingly regulators are approving therapies at earlier stages on the basis of less robust evidence. So, for example, European Medicines Agency used to require what's called phase 3 studies. These are quite large studies, randomized to the intervention and to the control group. increasingly, they are willing to approve a new drug on the basis of phase 2 data, which may well be a single-arm study where all the patients got that therapy. Now, for the purposes of drug safety, that might be all right. You might be able to form a reasonable judgment as to how safe the drug is by looking at a single-arm trial. But for purposes of economic evaluation or purposes of obtaining value for money in your decision making, that sort of data is much more limited and much less helpful. For all the reasons when I was talking about indirect treatment comparisons, we would rather have a randomized head-to-head trial. So that's one challenge. And the challenge is this, that with the regulators approving drugs at an earlier stage, there's a real pressure on the health technology assessment bodies to make decisions at an early stage. Another challenge is what we might call the clustering of health technologies.
Is there any feature of those drugs that are being approved earlier? Are those drugs targeting, for example, special conditions or rare conditions that are not really having any other alternative for treatment, for example?
I think that's a fair point. I think not always, but on a significant number of occasions, these will be conditions where current therapies are either absent or noticeably poor. And so we don't want to wait a long time for a new therapy. If something seems to be working and seems to be safe, we want to get it approved more rapidly, which is perfectly reasonable, but it means the decision making is being made on the basis of much more limited data. And there's an appreciable risk that from a health sort of safety point of view, we could be making the wrong decision because the phase 2 data typically is a much smaller study. And it may be that some of the bad outcomes are relatively rare and you need a bigger study to capture them. But yes, there can be quite persuasive reasons for earlier decision making. Equally, I think there's quite a strong commercial push as well, because it is very costly to develop and thoroughly test new drugs. If you can get them approved sooner, you can, as it were, get the payback sooner. If you can get them approved sooner, you don't have to do quite so much testing, and you can therefore reduce the costs of drug development. So there's that as well. Okay, clustering of health technologies. This can be, I think I've got a slide on it coming up. This can be a bit of a challenge. By clustering, I mean, if we stick with the drug example, several related new drugs coming along almost at the same time or one after the other. Now that causes all sorts of problems, particularly with respect to comparators. We'll see an example in a minute. Another challenge involved in using economic information is achieving and maintaining stakeholder engagement. And I touched on this, I think, on Tuesday. There's not much point looking at the cost effectiveness of new drug if you aren't going to say no sometimes. If you're always going to say yes, don't bother looking at cost effectiveness. The information is no use to you. It's only useful if you're going to say no sometimes. If you're going to say no, you've immediately got a problem with stakeholders. The stakeholders here are predominantly the manufacturers, clinical groups, patients, patient groups, although arguably also the general public are stakeholders. And so if you're saying no sometimes, how do you ensure that you're not alienating, driving away your stakeholders? How do you keep them involved? So there's a challenge. Another challenge is introducing economic information to decision making. It requires a lot of capacity in the system. It requires capacity to produce economic evaluations. It requires capacity to critique economic evaluations. You have to critique them. You can't just take at face value somebody says this is cost effective. It's got to be critiqued. And then among the decision makers themselves, it requires capacity to interpret the evidence. What does it mean? Now, we might all think, well, we know what £25,000 per additional QALY gained means, but it's not what the headline means. It's to what extent can we rely on that number? And to understand that, you need to have some understanding of how the number is being created. And decision makers need that. So that's quite a lot of capacity that doesn't exist naturally in the system. I mean, if we took the context of Japan, if Japan really wanted to embrace health technology assessment on a big way, you're way short of adequate capacity to I mean, I think small steps are fine, but it'd be quite difficult to move rapidly to a routine evaluation that involved economic information. And then the final challenge I've got here is that there's a need, or we need, the budget set for healthcare and the cost effectiveness threshold that's selected to be consistent with one another. This is the affordability issue. If they're not, if the budgets are out of sync with the cost effectiveness threshold, you're going to create problems rather than reduce them. Well, I've got a little bit more to say about some of these. Clustering. This is another example. This is second-line renal cell carcinoma. A rather nasty condition, but the good news is there's quite a few treatments that to some extent work. There were already existing treatments. I've forgotten what the dominant one was, but from January 2016, we've had a succession of new treatments introduced. Nivolumab, everolimus, cabozantinib, and then lenvatinib plus everolimus. Now, this bit, scope, is when the issue was identified. This is a new drug. These are the likely comparators. Identifying the decision problem. Guidance, moving forward in time, is when eventually a decision was made and the guidance was issued. So if you like, this length of the line here is essentially the time it's taken to go from saying, I think we need an evaluation of this, to a statement about yes or no and why, a decision. And as you'll see, we've got a sort of clustering or overlapping. Before nivolumab appraisal was resolved, everolimus was underway. Before everolimus was resolved, cabozantinib was being evaluated, and so on with lenvatinib. Now, that is going to be a real decision-making challenge. So, what should everolimus be compared to? Well, probably it should be compared to nivolumab. But as it's been kicked off before nivolumab was approved, everolimus wasn't getting compared to nivolumab. And then before everolimus concludes, in fact, indeed, before nivolumab concludes, cabozantinib appraisal started. And so again, you might say, well, what we really want to know is how cabozantinib compares to everolimus and nivolumab. But actually, and I can't remember the drug before, we're comparing all three of them to something that was used several years earlier. So it's a challenge. I mean, it's great that we've got these new technologies coming along, but it's like buses, isn't it? You wait for a bus, not in Japan probably, but in other countries you wait for a bus, you wait a long, long time, and then three come together. I'm sure in Japan that never happens. I have to adjust my talks culturally. Yeah. So this sort of sequential decision making in the presence of a treatment cluster is quite difficult. There's an issue around what you compare to. Another problem is disagreement regarding common comparators. So these appraisals will each have had to make some assumption about how we're going to model survival. They'll have all had to make assumptions about what score do we attach to stable disease health state? What score do we attach to progressed disease? Now, you'd rather want them to make similar assumptions so you can get a better comparison, more consistent comparison. But of course, the case is being made by different manufacturers. And manufacturers tend to make the case as strong as it can be for their own product. So there is frequently quite a lot of disagreement about these common shared comparators. All these cases, they're all looking at the same decision problem. This was an example of second-line metastatic renal cell carcinoma. Frequently, they've got different model structures. And again, that makes comparison harder. And then, in some ways, the saddest element is this hidden data. The sum of what we know about these drugs is much greater than what any single appraisal knows about the drugs. So the manufacturers, for good commercial reasons, are not sharing information with each other. Now, of course, if you said, well, let's look at all these drugs together, let's pool all the information, one would anticipate we'll get a much better decision as to what is the best way to treat these patients. By best, I mean not just most effective, I mean best value for money. But we don't. We're taking individual sequential decisions and we're not sharing data. So it's a challenge. Right. That was a clustering. Yeah, I've mentioned stakeholder engagement. Yes, the budget. I want to say a little bit more about the need to have the budget matching in some way or consistent with the cost effectiveness threshold. Where has it gone? Yes. Right, a graph. I'm afraid economists love graphs. That's because they're not clever enough to use equations. We like equations as well, but graphs we love. Pictures. Imagine along the horizontal, we're measuring, in this case, NHS expenditure per year, substitute Japanese system or any other country you wish. So this is the amount of resource going into healthcare each year. And so just now, the budget is at this level E. And that's the total amount we're spending on healthcare. On the vertical, we're measuring marginal health gain. So what health benefit are we getting? Probably measured with QALYs. What health benefit are we getting from the money we're spending? Now, as a sort of thought experiment, you could take everything we're currently providing and order these activities in terms, starting with those that give you the most health gain. And then less health gain, and so on. Okay, so the marginal health gain an activity gives us. And we're ordering the activities so that we've got the activities that produce the highest marginal health gain up here and the lowest down here. Okay, now in this example, I'm being quite kind to the health system and saying that even the worst thing we're doing to patients, even the worst activity, is still producing a positive benefit. EA. Okay, so that's everything we're currently doing. Now imagine everything that we're not doing, we're not providing. So there's a series of things we could be doing for patients. This might be new drugs or whatever, diagnostic tests, you name it. And we could order them in terms of those activities which produce the highest marginal health gain down to the lowest. Okay, so the line HA is everything we're currently providing. The line CF is the things we're not providing. So now imagine we did everything. So we sum together, adding horizontally, the two curves. So we get a new curve, new line, H, D, B, E, F. That's the adding horizontally. That's if we did everything. If we did the things we're currently doing, but we also did all the things we're not currently providing. Okay, now imagine the budget has remained the same though. The best we could do with this budget would be achieving a marginal health gain of EB on that would be our least, as it were, productive activity. Right now, the activity that's giving us the least benefit is here. It's got the marginal health gain of EA. And so looked at this way, we should really stop doing these activities or stop giving these drugs, treatments, and using the money released, we should start doing these activities. These are the best things we're not doing just now that we could be doing. These are the worst things we're doing just now that perhaps we shouldn't be doing. Now, if that's to happen, if we had a cost effectiveness threshold at EB, then there's no problem of the budget and the threshold being out of line. They're consistent with each other. If we had a cost effectiveness threshold which implied an activity must have a marginal health gain of EB, and if it doesn't, it shouldn't be done. If it does, it should be done. If we did that, we could afford to do everything that meets that threshold. The budget's big enough. But there's no mechanism to make that happen currently. And therein lies the problem. So for example, in England, as I was saying earlier, it looks as if the NHS can turn money into health at about £13,000 per QALY. Meanwhile, we've got a cost effectiveness threshold of 20 to 30,000, and so new technologies are being approved which are actually going to reduce health in the system, because by paying for the new technology, you're giving up some existing technologies, and those existing technologies can produce QALYs at £13,000. So that's a problem, a challenge, getting the cost effectiveness thresholds and the budget into line. So what I've reviewed the challenges in making robust estimates of cost effectiveness. I've reviewed a bit more briefly the challenges in then using that information as part of your priority setting system. I now should close, I guess, with some of the potential advantages of the economic approach. Now, whether we call this an advantage or we call it a sort of belief or an assumption, let's call it a belief. The belief is that if you can take decisions on a more consistent basis, you'll have better use of scarce resources. And the whole drive of using an economic approach is to try and make the series of decisions, take these decisions on a consistent basis. And so the expectation is by using this economic information, you will end up with better decisions in the sense that from our limited resources, we get more benefit. That's the belief. Of course, what I've just been talking about, the idea that cost effectiveness thresholds and budgets are out of line, is just the reverse. We're not getting better use of resources, if that's true. Another potential advantage of an economic approach is it does give the opportunity for really quite widespread stakeholder engagement. Now, I haven't emphasized a lot of the processes taking place, but for example, manufacturers are heavily involved because they produce the evidence. They produce what they sometimes call a sort of evidence portfolio, or more in marketing, they call it a value proposition about what their product offers. Yes?
That now they may pursue some, like the precise medicine, for example, that new drug is not, how can I say, effective, have efficacy to all of the total patients, but they do that to some subgroup.
Yes.
I just wonder whether the cost effectiveness research to, how can I say, identify some subgroup which is very good cost effectiveness in some subgroup.
Right, yes, sometimes called precision medicine, sometimes called personalized medicine, stratified medicine. Yes, it's a very interesting area. We're gradually learning more about precisely which patients will get the benefit from a particular drug. Now, this is a very exciting proposition because right now, with some drugs, a lot of patients don't get much benefit, but they may experience quite a lot of adverse effects. And of course, as a system, we experience the cost of treating them, but not getting a benefit. It's not clear whether precision medicine is going to improve cost effectiveness. It works on the quality side. If you've got a good biomarker and you can target your therapy better, you then don't treat people unnecessarily. You don't give them adverse effects. So the net effect on qualities is better. What happens to the costs is less clear. With a lot of these therapies, you continue using them until there's no evidence of benefit or the patient progresses, which is often the sign there's no evidence of benefit. But if they don't progress, you keep giving them the drug. And so what's not at all clear is what the change in costs will be. With targeted therapies, it looks as if the cost per patient will go up because those patients you would have stopped giving the drug, you don't even start. Now you've got biomarkers. So the patients you're giving the drug to are going to go on longer and get more of the drug. So we've got a situation where qualities are going up slightly, but costs are also going to go, per patient, are going to go up. And the question is, which is going up faster? If the costs go up less than the qualities go up, it's becoming more cost effective. The other way around, it's becoming less cost effective. We don't know the answer yet. I've got a PhD student researching it just now, who'll come up with one answer, I guess. I'm not saying it will be the final answer. But it's a very interesting area because there's a huge push on to encourage precision medicine, personalized medicine, targeted therapies. And what I'm less clear is whether it's a sort of real advance or it's more something sort of marketing. It's also, universities love it because you've got lab after lab happily searching for biomarkers and testing one and mice knockdown models as you knock out one thing or another. So it's very exciting from a research point of view, but I think it's too early to say if it's going to absolutely transform medicine. See, this will be on YouTube next year or whatever, and then people in 20 years' time can play it back and say, look at this idiot. He thought it was marketing. He didn't realize it was going to transform medicine forever and ever. I should probably record 2 versions where I speak very positively about precision medicine and, of course, how it's bound to change life. But it's it's an interesting question. It's a very interesting area. Right. Another potential advantage is, and actually while we're on opportunity for widespread stakeholder engagement, you can give patient groups a lot of access to the whole system. And at least in England we do. And clinical groups as well. Clinical experts get a good opportunity to give evidence. Increased transparency and contestability of decision making. If you don't have explicit processes, such as you require when you look at economic evidence, you have much less transparency. Decisions are taken, but you don't really know why a decision was a yes or a no. If you wish, you can go on a nice website and see exactly what evidence. There's some redactions because of commercial confidentiality, but in effect you can see exactly what evidence a committee has looked at when it made a decision. When you read the guidance, there's a whole section of guidance which explains why the committee made the decision it made. So the system is much more transparent and also it's contestable. There's an appeal system whereby if manufacturer or a patient group don't like a decision, they can contest it and if not get the decision changed, they might get it looked at again, which may then change a decision. Another one is arguably there's less opportunity for regulatory capture. So that's the sort of jargon. Regulatory capture is where if you've got a Ministry of Health makes decisions on new drugs and you've got a powerful medical lobby or a powerful pharmaceutical industry, over time, through various mechanisms, the decision-making body gets captured. They sort of begin to fall in line with what their client group, maybe the pharmaceutical industry, want. Now, there's less opportunity for that if you've got an explicit system of health technology assessment that's looking at the costs and the benefits, that is publishing the evidence, that is indicating how and why a decision was made. Another possible potential advantage is it can provide a means of establishing an acceptable price. What should the price of a new technology be? Well, one guide to it is if we know the cost effectiveness, in other words, if we know the additional benefits produced at what additional cost, we can begin to have quite an informed discussion about price. A major element of the cost effectiveness will be the price. It's not the only driver, of course, but a major driver is the price. Lower price, more cost effective. Higher price, less cost effective. And so using the economic approach of looking at things like cost per quality gained can at least guide you to a price limit. You could say, well, above that price, this is not going to be a good use of resources. So that might be useful. The final thing I've got here, it's more of a, well, I stress the potential advantage, We don't have good evidence on this, but I suspect health systems with well-established health technology assessment processes can obtain lower prices for new technologies. The evidence of that is in Europe, where HTA is quite widely used. The prices we are paying for new drugs are significantly lower than the prices, for example, in the United States, where they don't have anything comparable in terms of HTA processes. Now, if that is true, that's quite an advantage. I don't, unfortunately, know how to. I don't know the comparison between prices in Japan for new drugs and the comparable prices in, say, Germany, England, France, the United States. It would be very interesting. I suspect Japan pays quite high prices, but then, of course, taking the system as a whole, every 2 years you can negotiate down other payments in the health system, and so it's not all bad news. So let me just be absolutely clear here. I want to call these potential advantages. I think it would be reckless of me to sort of be absolutely categorical and say, you know, these are advantages that you've really got to, you really must embrace health technology assessment. You've got to take the economic approach and then get these advantages. I'm not doing that. I'm not doing a sort of sales pitch. I think these are potential advantages of an economic approach. So in summary, and I'm actually going to finish on time. This is luck rather than judgment, but there we are. I'll claim credit. This is an important topic. It's big sums of money. It's health. We all care about our health and other people's health. So it can't really be more important. It's very exciting because it's rapidly evolving. Now, I haven't really maybe got the flavour of that across, but I started on a nice appraisal committee in 2003. So I've been doing that particular role of looking at new drugs for 15 years. And things have changed so much in terms of the sort of evidence that's available, the methods that are available to look at that evidence. And they continue to change. Now, as I've emphasised throughout these lectures, there are numerous challenges in terms of methods. There really are. I mean, I guess you guys haven't been very exposed to the methods before, and now you're probably coming away thinking, oh, I thought it was more robust than that. This is terrible. They're taking decisions on that? They've asked the general public to do a time trade-off, and that's determining what drugs are available. You know, I can quite understand you might feel that way, and I think it's a fair response. What I haven't gone into a lot of is the sort of processes. I've emphasised more the methods, but there's also numerous challenges on the processes. But I would like to claim that the potential benefits from a successful system for determining healthcare priorities are large. So it's a sort of prize worth working for. And I think that's my last slide. Yeah, good. And thank you for your attention.